All right, here we go. So again, part A is just to plot the point. So this right here is the same concept as your X and your Y. So a different way to write this, you could say 2 comma 1. So if you're trying to graph this, I don't know where you put it on your coordinate plan. I'm gonna put it right here. I'm literally gonna go right 2 up 1. So here is, we'll call it A for part A. Got questions? All right. Any questions on how to plot it when it's in this form? All right. D says to find this. I tell you that D is this right here. So this is the D. This is your XY right here. So to rewrite this, this becomes 3, 0, 0, 3, and then 2, 1. Do y'all remember how to multiply matrices? So this right here, this D, when I tell you let D be D parentheses XY equals this is your D.
I did
Oh, you could do it that way too. Yeah, I didn't think about that. I was just thinking that you could just replace the 2 and the 1 for the Y and X in the matrix and then just multiply it out. But what you would do is you form the equations, now go replace X and Y with 2 and 1. So regardless of which direction you went, remember to multiply. I chose a different color. Take this row times this column, and then take this row times this column. So this becomes 3 times 2 plus 0 times 1. And then this becomes, again, this row times this column. This becomes 0 times 2 plus 3 times 1. You can do this process or do it just all at once. It does not matter to me. I understand if you understand. But 3 times 2 is 6. 0 plus 1 is, sorry, 0 times 1. And then 6 plus 0 is 6. Very good. And then 0 times 2 is 0. 3 times 1 is 0 plus 3 is 3. Let's limit the chatter though, guys. Thank you. Questions on how to do what we did the last 2 days? Yes.
this.
What words did we? I know, but what words did we use to indicate that something doubled or stretched or condensed or anything like that? Dilation, scale factor, both of those are great. Like what I'm, so if I graph this right now, this is now 6 comma 3 because that's what it tells us to do is find it and then plot it. So this is the same thing again as 6 comma 3. So I'll go 3, 4, 5, 6. 1, 2, 3. And we'll call this B. So we can see that this point went from here to here, and it's asking you to describe the geometric effect. Well, if it looks like it's doubled or triple, we can say that this had a dilation of a scale factor of or by what? Is it 2? Be 3. Very good. Because if you multiply this by 3, I get 6 and 3. And then we also learned last 2 days that if it is in a dilation, the form is A, or sorry, my bad, not A. It was 0, was R0, 0, R, which is in this same kind of format that this is in. So this right here ends up being my R, which represents my dilation. So you should be able to just look at it and know what your geometric effect is, or we can do the work and see, hey, it just tripled in length. Right? But that's how you write it in smaller words instead of like 5 paragraphs to indicate that it tripled in size. Any questions on the last 2 days? Before I like to move on, was there any major questions on problem sets 1 through 8?
I was pretty confused on the 8 part.
Part 8, okay.
Or not. Wait, no, not 8. 7. Like I didn't know what this was at.
Oh, so we had to create a matrix that represented that as a linear
Does this
transformation?
look wrong?
No. So this right here would be more along the lines of like that right there would be 4004 because that would be your R dilation. And then what you would do is you would plug in for this right here, right there. So basically this right here, like your scale factor is your R and your rotation is your theta, and you just plug it in here to calculate your matrix. So just a heads up on number 7, if you go back to that lesson summary, you would use the matrix of R cosine, negative sine, sine, and or R sine and R cosine, and just plug in whatever your dilation or your rotation is in to calculate what those numbers are, and that's all you had to do.
You said tutorial that was recording?
Yes. Any other outstanding questions on the problem set? Again, guys, we gotta limit the conversation. Good. Good. All right. All right, let's move on to today's stuff. Again, it's going to be the same stuff, but with application. So on this one here, it says let f of t. So now we're kind of seeing some physics type thing. F of t in physics is like time displacement of feet or distance that a ball goes up in a projectile motion. So that's kind of what we're going to be seeing all day today. So where t represents time measured in seconds, p or your f of t will represent the position of your moving object in time. And if the object starts at the origin, how long will it take it to reach 12, 24? So if you start at the origin and you're displaced to now 12, 24. So again, in a physics outlook. So you hit a ball somewhere here, and now we're at 12:24, and you're somewhere here. And we're just asking, what is the time displacement? How long would it get there, depending on what we have here? All right. So that's what we're going to do. That's what we're going to look at. So what that 12:24 is, that is your result. That is your answer. So this is what we have. This is what's given to us. T0, 0, T, 2, 4. This is what's given to us. And then it tells us, hey, the answer is 12:24. Again, we're just rewriting a coordinate as a 2x1 matrix. And now I need to go, all right, what would that T be so that I can produce this answer? So what we can do is using our matrix multiplication that we did the last 2 days is we can go ahead and do this row times this column, and then it would equal this number. So in short, this would be 2 times t plus 0 times 4 equals 12. And then if you do the same thing here, is there a question? Okay. So then this would just be 0 times 2, put that in parentheses, and then 4t, which is the same thing as t4. And that would have to equal then this 24. So now we've just established 2 equations. Now, what's really cool about this is once you establish one, they'll both give you the same answer, or they should if you wrote it correctly. So to make this a little bit cleaner for us to do, what is 0 times 4? 0, so that would go away. And I really just have an equation of 2t equals 12, which states then that t equals what? 6. Good, so we would just divide both sides by 2. Same process here. I don't need the 0 times 2. So 4t equals 24 would give me 6 again, because I would just divide by 4. So t would equal 6. So regardless of which equation you get, you should get the same result. Go ahead and ask the question. Oh, I got you. So like if you start at the placement of 2, 4, what do you have to multiply to get to 12, 4? You just multiply by 6. Yes, right now that works when it's just a dilation. Right now it's just a straight shot. But starting at the, well, that doesn't matter. Is that right now we just have a straight shot, but what happens if we put some arches in there? Now it's going at a curve of displacement at 72 degrees. Now we're gonna have to do a little bit more work there. But yes, technically these type of questions to starting off, you can definitely get the answer real quick. This is a word problem just like it is in physics. Since t is in seconds, don't forget to add your units. All right, but that would be it. So it would take 6 seconds to have this moving object hit that 12, 24 with the given information presented to us. Any questions on today's stuff? So again, it's the same math as what we were doing the last 2 days. We're just putting application in it. So same part here with 2a here. I give you an equation, or I say g of t is equal to this guy, and I want you to find the k value given that it's equal to this, and I give you the time, and I say within 2 seconds. Okay, so when we work this out, this becomes, again, kt 0, 0 kt times 2, 4, and it has to equal 1224. So using what we've learned, I can take this row times this column, and it would equal this result. Right? And again, it's telling us the t here. So it's telling us that the t is 2. So when I plug this in, I will get, well, 2 times kt, or that works. But instead of kt, I'm going to go ahead and, well, I'll do that in the next step. We can put it all together. Good. Plus 0, 4, you're good. You're good. 0, 2. Okay. I like putting the numbers first, but you're totally right by saying what you're saying. And then equals 24. And again, with the fact that t is equal to 2, when I back substitute this in, this now becomes 2 times 2k. Do I need the 0, 4 anymore? No. So then that right there would equal 12. What's 2 times 2k? And then what would I do? Divide by 4. So k equals what? 3. If done correctly, this equation should give me the same conclusion. I no longer need 0 times 2. I now get 4 times 2k, because again, t is given to me as 2. So it was originally kt, but then t is 2. So when you plug in 2 for t, in mathematical grammar, the number comes before the letter, but if you wrote it as k2, you're not wrong. And so this becomes 8k equals 24, divided by 8. That's a bad 8. But then k would equal 3. So again, you don't have to solve both of them. I just want to show you, no matter which equation you set up, you should be getting the same value. We all good now? Bless you. You're welcome. Go ahead. So you understand that it was KT right there? Okay. The directions told us, hey, find this in just 2 seconds. So then I'm able to put 2 in for the T. So that became, and I wrote it as 2K rather than K2, just because it looks cleaner to have the number than the letter.
Hypothetically, if they said like time was like a different variable, F or something, they do that to find most.
Oh, no. In a word problem type stuff, yeah, I see what you're talking about. T is usually always time. Yeah. Now I could throw out the fact that this does nothing with time and then say, hey, this is now KF, find it where F equals this value and have no meaning. But they would never say, all right, let F be time. Usually T is always time. Now I say they won't do that. Somebody out there could say, hey, let F be time now, but typically in word problems, T is always time. And F of T is usually position or displacement or feet and stuff like that, height. Any other questions on 1 or 2A? All right, so I want y'all to do the same thing on part B, but this time let T equal 30. Go ahead and make sure you can do this on your own. We'll check it and then move on to the next step. Is 2B is still part of 2A. So it's going to be the same formula as on number 2. The only difference is now I want to see what happens when t equals 30 because I'm looking at 30 seconds. Again, when you solve it and you're unsure of yourself, when you set up the second equation, it should equal the same thing. And if you do, you're good. Mm-hmm. Are you on 3 already? So in that case, we're still dealing with complex numbers. So it'd actually be written as a plus bi. But as a coordinate, you're correct as saying x comma y as well. Yeah. Because does it tell us? I guess in that situation, it doesn't tell us the position of a complex or polar Artesian plane, but yes, you could write it as x comma y. Didn't get the same answer. Check both. Yeah. Yeah, this one has a fraction as an answer. Yeah. If you get a fraction as an answer, you did it right. If you got a whole number, check your work. Make sure you all at least got that set up. Everyone good so far? All right, let's go ahead and solve it then. So again, I don't need this 0 times 4 here. That's not always how it's going to work, just an FYI. Right now, we're just dealing with dilations. Then 30K times 2 would give you 60K equals 12. And then I would do what? Good. And when you do that, we get perfect. If you got 5, it's because you typed it in the calculator as 60 divided by 12. Make sure you type it just like you have it written on your paper. Same concept here. This will go away. This is now 120K equals 24 divided by 120. And you should still get 1/5. Very good. Again, I'm not asking you that you have to solve both of them. I'm just stating that if you do solve both of them, they should give you the same answer. And if not, you've done some work wrong. So it might be good practice to solve both, huh? But yeah, because if you're unsure if you got the correct answer, if you solve the other one and get the exact same answer, now you know you did do it correctly and get a little more confidence there. All right, so number 3 is kind of the same process. It's just now it wants you to try the process with addition. And it's again telling you 3 different examples for time. So I'll do 1 and I'll let you do 2 of them. So if I let t equal 0, I get the following. What is 2 plus 0? 2. These are always 0. And then 2 plus 0 is still 2. 5, 7. And that's it. We're trying to figure out what that's equal to. Before I move on any further, does everyone understand how I went from this to just this? Okay. I just plugged in t with the corresponding values. And you'll do that. You'll do 1 and 2 on your own. But I just plugged in 0 to get this. After that point, you just do our matrix multiplication, which is going to be 2, 0 times 5, 7. What's 2 times 5? 10. 0 times 7 goes away. We don't need it anymore. 0 times 5 is, that goes away. 2 times 7 is 14. So there's your answer. You can then rewrite it as 10 comma 14 as a coordinate. And that's pretty much it. Questions on that? So do it for t equals 1 and t equals 2 real quick to make sure you understand how to do that. And then we'll add continuous step to this. Mm-hmm. Not necessarily because you're adding. So like here, what is 2 plus 1? Gotcha. Yeah. So that's what we just got done doing. Now we're doing some steps with addition. So yeah. Stop the yawning. I don't know. I wasn't yawning until just now. Bless you. All right, we're good? All right, let's check it. T equals 1, you should have gotten 3, 0, 0, 3. And then when you did the math here, you should have gotten 15 and 21 and got 15 comma 21. Everyone good there? The next one should be 4, 0, 0, 4. And so now you should have gotten 20, 28, which is as follows. Everyone good? Solid. All right. So this next part here, it says now write this as an equation. So what we know is that this is simply 2 plus t, 0, and then 0, 2 plus t. But if you don't know what these coordinates are, well, I guess let's just keep it as that. We'll just keep it as that for now. What would this look like if you didn't know what t was? Hmm? You're close. You said 10 plus x? Not quite. Closer again. So let's take this. And remember that each one of these is an element on its own. So 2 plus t is an element, and I'll multiply it to 5. If I multiply 5 to 2 plus t, I would get what? 10 plus 5t. All right? Because I would have to distribute the 5, and then I have the 0 times 7, which is just a wash. Because the 5, so it'll look like this. It would be 2 plus t times 5. So in reality, this 5 would have to be distributed all the way in there, which would then give us 10 plus 5t. And the same process here, if I take this, again, knowing that each one of these is individual elements, 0 times 5 is a wash, and then I would distribute this 7. So this becomes 2 plus t times 7, which is now 14 plus 17. So now you just establish an equation in which now I don't have to do all this matrix multiplication. If I knew what t was, I could plug it in, calculate real quick. And we can check that if you want. Plug in 0, 5 times 0 is 0. I get 10. Plug in 1, 5 times 1 is 5. 5 plus 10 is 15. Plug in 2. 2 times 5 is 10. 10 plus 10 is 20. So it all works out. That's what it's basically established in there. Now we established this so that when we look at part 4 here, oh, it wants me to now write this transformation as a matrix transformation, meaning have the 2 by 2 and the 2 by 1. And literally, I'm just going to bring it right back up. I know it's kind of all over the place. But basically what it's doing, it's getting you here, or it starts you here, and then wants you to get to this point. So how would I go from here to here if I was going backwards? What's that process called? What's reverse multiplication? Other than division, what's another word for that? Not subtract. Starts with an F. Factoring. So we can actually factor something that's in common out. And then once I have it written like this, I can now rewrite it like this. And that's what it's asking. We just went in this direction. Now I'll be able to go backwards with it as well. So when I do that, I have my 15 plus 5t, and I have my -6 minus 2t. I'm going backwards from where my answer was. So what does 15 and 5 have in common? 5. So when I rewrite this, I can say this is 5, and then in parentheses, this is going to be a what? How would I figure out what's left when we talk about? Good. 3 plus t. Very good. On the bottom, what does -6 minus 2 have in common? They have a 2, but the goal is for the two binomials to be exactly the same. So instead of just a 2, what would I want? I want to pull out a negative with it, because if I pull out a -2, what's going to happen to both these signs? If I make this a negative, what's going to happen to both of these signs? It has to be a positive, which is good because that's what the inside of this one is. So then if I factor out a -2 out of -6, what's left? 3, and then plus t. And you know you did this correctly if these guys are both the same. So now to rewrite it like it was originally given to me, the thing that is what's left, that becomes your 2 by 2 matrix. So that's your 3 plus t, 0, 0, 3 plus t, and then 5, -2. Now, what's also cool about this is since you now know this process, to go backwards, you can always check yourself. If I multiply this row to this column, does it get me back to this conclusion? And it will. 5 times 3 is 15. 5 times t is 5t. Because the 0 will wash out the -2. Questions on going forwards or backwards on this process? To here? You just factor. Got the 3 plus t. So, okay, so the way I taught factoring, I guess more of an algebra 1 kind of concept, is I teach kids, look at the smallest number. Ask yourself, does the smallest number go into the largest number? If it does, that's your greatest common factor. That's what you're going to pull out. So I put the greatest common factor there. Now, that's not always necessarily true. Sometimes this could be a different value, and then you'd have to factor that. We'll get to some of those later. But then, yeah, so you put that GCF on the outside, or greatest common factor. To figure out what's left inside, you're going to divide your polynomial by that greatest common factor. So 15 divided by 5 is what? 3. 5t divided by 5 is what? T. If you're unsure if you did it correctly, you should be able to FOIL this back out. Or sorry, FOIL, sorry. Distribute this back out, and it should get back to this point. So 5 times 3 is 15. That worked out. 5 times t is 5t. That worked out. So that's a way you can check yourself to making sure you factor correctly. Does that make more sense? Right. Any other questions? All right. Now, to put more meat on this, let's work out this next problem before we talk about it as a geometric description. So number 5, it says an object is moving in a straight line from 18, 12 to the origin. So it's coming back over a 6-second period. We're going to find the function that gives this a position after t seconds. We're going to write it in this notation where we have a function for x and a function for y. Don't stress out about that. That's literally our normal stuff. And then express f of t as a matrix transformation. So for starters, this right here represents your x. This represents your y. And we have a 6-second period going towards the origin. So for this 6, what kind of value would that be if you're here and you're going towards the origin? Not positive. You're going towards the origin. It'd be a negative. So whatever this represents, it's going to have to represent it as a negative because I'm going backwards into the origin. Now, the only issue is you don't know what rate that is. So for our x of t function, I can calculate it by starting at 18, subtracting 6. I just don't know at what rate. Typically, what letter do we use if we don't know something? X, but in this case, you're looking for an equation with x. So I'm going to use the k that we used at the beginning of this lecture. And I'm going to say some value k. Right? Once I determine that one, I'll be able to determine exactly when to get to that point. And so with this now as a setup, I can now form my y of t in the same way. And how would I do it? Perfect. Has the same time lapse. We just don't know the rate. All right. So now that we've established that, we can now rewrite this in this form. So we'll say f of t. Oh, it did use a t. And I used k over here. Oh, actually, I'm going to pause there. I just now caught that. I know where it's heading. I know the answer. What's the answer? 0, 0. So therefore, this right here has to be equal to 0, and this right here has to be equal to 0. So now I can actually go calculate that rate. Now the k should be the same on both, just like before, but we can check both. So how would I solve for k in this case? So I get negative 6k equals negative 18. Then what would I do? And so negative 18 divided by negative 6 gives me you're good. 3. If you're unsure if you did that correctly, just solve it again. What would I have to do to solve this bottom one? So I get negative 6k equals negative 12. Ooh, what we got going on here? So what's k going to equal here? 2. Fascinating. Okay. So we have a different rate of decreasing for our x and our y. We're going to have to change values. I can't use k for both. What's a different letter you like? Sounds good to me. They got different speeds to get to the 0. Well, if it's a straight line, but I guess in a sense, if you got one at 18 and 112, it makes sense for the 18 to go at a faster speed to get to 0. You're going to get to 0, 0 at the same time in 6 seconds, but the rate of decrease for the 18 or for the 18 and 12 has to be different. I didn't even think about that. So there's W. There's W equals, and then W equals. All right. So we just changed that to W. Same process, but our speed of that we're decreasing is will be at 3, and our speed of decrease will be at positive 2, ain't it? I'll put a negative there. All right, so 3, 2, that would be our spot there. So what we can do now is when we write this out as an answer, as an equation, we get x of t, y of t. Here is our information, but this time, what do we want to use? If we don't know the time, instead of just saying 6, let's just go replace it with that t function. So if we don't know time, so that's what this column was, to write out an equation, we would have to say, all right, this is going to be 18 minus t3, because we now know what k is, but we'll write it as 3t. And then this one here will just be 12 minus, we'll call this t, w was 2, so that become 2t. So we got the answer here, the speed of your x and your y value, but the issue is it wants us to write the answer in this notation. So it wants us to establish an equation for all x time and all y time with this ratio going on. So I kept the ratio that we solved for here. I just replaced the 6 with a t. So I can now calculate what would it be at 5 seconds, 4 seconds, 3 seconds. I can easily find my displacement anywhere on the map. So any questions there on why I went to this direction? Right. So then to write as a matrix transformation, we can now do what we did on the previous problem. What does 18 minus 3t have in common? 3. So I can now factor out the 3, and what would be left? Okay. On the bottom, what does 12 minus 2t have in common? 2, and what is left? That's a t, by the way, right here. This looks like a... Yeah, this is 6 minus t, and this is 6 minus t, but it looked like a 6 minus 6. So then just like before as well, I can rewrite this then as 6 minus t, 0, 0, 6 minus t, and 3, 2. Go ahead, what's the question? I definitely put the parentheses to separate it. Oh, it did, yeah, yeah. Look like 6 minus 6. Oh, I see what you said. 36 minus 6, yeah. So any questions there? So now you can go to Whiting and you can have a displacement with your bridge if it's going to make it through the weight or not. Oh, this is the process that we learned in the first 4 questions, that it was going to be like your function 0, 0 function. Yeah. Yeah, so this right here is what came over there. So we basically, the previous problem was just work and we went backwards. This one gave us some meat to it, but we're still going, here's the answer to the backwards part. Right? So for the last part, it just wants you to describe if a description of a geometric effect happens, can you now write a matrix out of it? This part's actually the easier part, very little work to do. So let's work through it. And this will wrap up pretty much today. And we should make it to lunch. All right, so this one says, write a rule for the function that shifts every point in the plane 6 units to the left. All right, so here's my original point, xy. If I'm affecting the shift left, what value does that affect, the x or the y? It's a negative, and it's going to be the x. Very good. So this now becomes x minus, because when we're shifting, it's either adding or subtracting, 6, and then the y stays the same. Questions? That's it. That's it. That's the answer. So if I tell you the geometric effect was left 6, it affects the x, I'm subtracting. So on this one here, what is the effect of xy? when I'm going 9 units up. Y plus 9. And then the X did not change. Pretty good. Let's put 2 shifts in this now. It says 10 units down, 4 units right. Is it down? Yep, -10. Perfect. We still saw it? All right, last one. What is happening here? Describe the transformation. Left 7, up 2. That's a 2. And that really concludes it. That's about as hard as it gets. I know. We did.